Snowpark stored procedure started timing out after 30 minutes, killing your daily pipeline. The culprit? A single skewed join key that forced one node to do all the work. Snowpark for Python is a library that lets you write data pipelines, stored procedures, and applications using Python, with operations pushed down to Snowflake for execution. In this tutorial, you'll learn the core concepts: the DataFrame API, stored procedures, and how to build full applications. Snowpark is a Python library that lets you interact with Snowflake using data frames. All operations are lazy, enabling pushdown optimization that runs computations directly on Snowflake compute, so only the final result is transferred. It also supports UDFs, stored procedures, and apps like PySpark, but native to Snowflake. First, install the Snowpark library using pip. Then create a session with your Snowflake connection details, ideally from a config file or environment variables. And don't forget to close the session when you're done. Install the Snowpark library with pip. Load your connection parameters from a JSON file, create a session, and verify the connection. Always close the session to free resources. Snowpark's DataFrame API is similar to PySpark, but with lazy evaluation and pushdown. You start with session table to create a data frame, then chain transformations like filter, group by, and ag without triggering computation until you call an action like show or collect. Data frames are immutable, so each transformation returns a new data frame. Read a table into a data frame, then apply filters, group by, and aggregation. The show action executes the query and displays the first 10 rows. Collect returns all rows as a list. Stored procedures allow you to run Python code directly on Snowflake compute using virtual warehouses. You register a function with session, sproc, register, and the first parameter must be the session object. You can also include Python packages, such as pandas, to handle dependencies. Define a function that takes session and parameters, then register it as a stored procedure. Call it via SQL. The return type is a list of dictionaries. Snowpark supports Python UDFs. Input rows are processed individually by Scalar UDFs, while vectorized UDFs process batches using pandas series, which is more efficient. Use the pandas UDF decorator for vectorized UDFs. Create a Scalar UDF that applies a 10% discount. Register it with the UDF function, then use it in a data frame select. For vectorized UDFs, use the pandas UDF decorator. The function takes a pandas series and returns a series. This is more efficient for large datasets. Snowpark can be used to build full data pipelines. Starting from a source table, the orchestration logic runs locally, but data frame operations are pushed down. You can filter new data on a timestamp column and then write to a target table, appending or overwriting as needed. This incremental load function gets the last loaded timestamp from the target table, filters new data from the source, and appends it. Use write, mode append, save as table to persist. To optimize Snowpark, start with your query. Use explain to see the query plan and filter early to reduce data. Review the optimized plan, then execute. Cache result helps with reused results. Avoid collect on large data frames, use show or to pandas with limits. Cache the filtered data frame so that multiple aggregations reuse the same data without rescanning. This can significantly improve performance. Debugging Snowpark can be challenging because operations run remotely. Use explain to see the SQL that will be executed. Enable logging in stored procedures using Python's logging module. Use session.sql to run diagnostic queries. Add logging to your stored procedures to track progress and errors. Use a stream handler to output logs and catch exceptions to log error details. Here's how it played out. A new data source introduced a skewed join key, a default unknown category with millions of rows. This caused one node to handle most of the work during the join, leading to a 30-minute timeout. The fix was to filter out the skewed key before the join, process it separately, and union the results back after applying a filter for unknown categories. This approach was a success, balancing workloads and eliminating the timeout. If your join key is skewed, like a default unknown category with millions of rows, one node gets overloaded. The fix is to add a broadcast hint, which distributes the small table and eliminates the skewed shuffle entirely. Avoid collect on large data frames. It pulls all data to the driver, risking out-of-memory errors. The fix is to use limit 10 before to pandas, which restricts rows so only a sample is transferred to the client. Always close your Snowpark session when done. In the broken code, the session is opened but never closed, which can lead to resource leaks and connection exhaustion. The fix adds an explicit session close, call to release those connections and prevent exhaustion. To diagnose issues, use explain to see the SQL plan. Query Snowflake's procedure history in information schema for long-running queries. Enable logging in stored procedures and use session.sql to run diagnostic commands. Time for common interview questions about Snowpark. Lazy evaluation means transformations are deferred and optimized. Stored procedures can accept table names as parameters. Vectorized UDFs are preferred for performance. Q&A time. Snowpark is native to Snowflake and simpler than PySpark. You can use pandas by specifying it as a dependency. Handle errors with try-except blocks and logging. To recap, Snowpark lets you write Python data pipelines that run on Snowflake. Use lazy evaluation, stored procedures, and UDFs. Optimize by filtering early, caching, and using vectorized UDFs. Debug with explain and logging. Thanks for watching. The full article and code examples are covered in detail at thecodeforge.io.